You ever feel like you're just drowning in numbers? Well, today we are completely flipping that around. We're going to build what I call a data detectives toolkit, and it's going to help you find the hidden stories inside any set of data. Let's get into it.
Okay, so picture this. You're staring at a long list of numbers. Could be test scores, prices, anything. Where do you even start? It can feel like a total jumble of noise, but I promise you, there's a story hiding in there. And today, we're going to find it.
So here's our mission, plain and simple, to give you the essential tools you need to become a data detective. By the time we're done here, you'll be able to look at a spreadsheet or a report and know exactly what questions to ask.
All right, every good investigation needs a starting point, right? A first clue. For us, that's finding the center of our data. You might hear the fancy term central tendency, but really, it's just about finding our first major clue.
Now, the first tool in our kit, and probably the one you already know, is the mean. We all know it as the average. The idea is really simple. You just add up all the numbers and then divide by how many there are. It's like if you shared everything out equally. So for 2, 4, 6, and 8, you get a nice, clean 5. Easy enough.
But here's where a good detective has to be really careful. What happens if we add one crazy number into the mix, what we call an outlier? So look at this new set. We have 1, 3, 9, 10, and then bam, 100. All of a sudden, our mean just skyrockets to 24.6.
So you got to step back and ask yourself, is 24.6 really a fair summary for a group of numbers where almost all of them are below 10? No way. That mean is being dragged way off course by that one single outlier. It's totally misleading.
And this is exactly why we have another amazing tool in our toolkit, the median. The median is just the number that's physically in the middle once you line everything up in order. For our data set, the middle number is 9. And look at that, the giant 100 has zero effect on it. It just ignores it. This makes the median way more stable and often a truer summary when you have those weird outliers.
So the really crucial part of being a data detective is knowing which tool to use and when. Think of this table as your little cheat sheet. If your data is pretty balanced, symmetric, the mean is great. But the second you see outliers, the median is your best friend. And just for the record, if you're dealing with categories like what's your favorite color, you'd use the mode, which is just the one that shows up most often.
So finding the center is awesome. It's a huge first step. But it is not the whole story, not even close. A good detective knows that you always need more context. Just knowing the average can actually hide some really important stuff. Okay, check this out. We've got two classes, Class A and Class B. And get this, they both have the exact same mean test score, 75%. Now, based on that alone, you'd probably think they performed pretty much the same. But did they really?
We need to dig a little deeper. We need to ask a smarter question. For example, which class is more consistent in its performance? This is where we have to look beyond just the average.
All right, now look at Class A. See how all those scores are bunched up, super close to that 75% mark? This tells us their performance was really consistent, very predictable.
And now, Class B. Whoa, the scores are all over the map. You've got students getting a 40 and others getting a perfect 100. It's the same average, but a completely different story. This class has really high variability. It's super inconsistent.
So how do we actually measure this consistency, or lack of it? We use tools for what we call spread. The simplest one is the range, just the highest minus the lowest. A much better tool, though, is the interquartile range, or IQR. It basically looks at the middle 50% of the data and sees how spread out they are. But the key takeaway is simple. A smaller IQR means your data is more consistent. Class A has a nice small IQR. Class B's is huge.
Okay, so far, everything we've looked at has been with data we have right in our hands. But what happens when we want to understand a massive group, like an entire city or all the customers of a huge company? How can we make a smart, educated guess about all of them just by looking at a few?
Well, that's where sampling comes in. It's a pretty brilliant idea, actually. Since it's usually impossible to ask everyone, the population, we just talk to a smaller, manageable group, the sample. And we use their answers to make an educated guess or an inference about the whole group. But, and this is a huge but, a detective has to know the traps. You can't just ask anybody.
Two of the biggest mistakes you can make are using a biased sample, like, only asking your friends who probably think just like you, or using a sample that's just way, way too small. Asking two people their opinion tells you nothing.
I mean, just look at this chart. That whole donut is your entire school. And that tiny, tiny little sliver, that's your group of friends. If you only ask them what they think, you're completely ignoring what everybody else thinks. Your conclusions about the school will be totally wrong. Your sample has to be representative.
And all of this leads us to what might be the most important part of our toolkit, the mindset. It's not just about doing the calculations, it's about how you think and talk about the results. This is the data detective's code of conduct.
Okay, if you remember just one thing from all this, let it be this. Because you're using a small sample to guess about a big group, you can never, ever be 100% certain. Statistics isn't about proof, it's the science of managing uncertainty. We're dealing in probabilities. And because of that, the words you use are incredibly important. A good statistician, a good data detective, uses cautious and smart language. You say things like, the data suggests, or it is likely that. This shows you get it. You understand the limits of what you know.
On the flip side, you have to watch out for language that's way too confident. Words like proves, guaranteed, or for certain, those are massive red flags. The second you hear someone making absolute claims based on a sample, your detective's spidey senses should be going off.
So just always remember this. A number, whether it's an average or a percentage, is just a summary. It's like the headline of a story, not the whole article. A great data detective always asks the most important question. Where did this data come from, and how was it collected?
So, I'm going to leave you with one last case to crack. You see a headline that says, a survey of 10 students found that 90% of them love math. Now that you have your detective's toolkit, what's the very first question that pops into your head? Think about that sample size. Think about bias. And you'll be well on your way to finding the real story.
Hey, welcome. Ever wonder how we know stuff? How we figure out if one thing is actually connected to another? Well, in this explainer, we're going to become data investigators. We're going to learn the basic tools to see the hidden patterns that are all around us. Let's get started.
So let's start with a question we've probably all asked ourselves. It seems like a no-brainer, right? More study, better grades. But how would you actually prove it? This simple question is going to be our guide, our first case file, as we learn how to look at data and find the real story.
So where does an investigator even begin? Well, the first step is always spotting the clues. And for us, that means we need to see our information. Our number one tool for that job is something called a scatter plot.
Now, before we plot anything, we got to talk about the kind of clues we're working with. It's called bivariate data. I know, it sounds super fancy, but trust me, it's simple. All it means is that for every single person or thing we're looking at, we're measuring two things at the same time, which gives us a pair of numbers. For instance, we could take a person's height and their weight. That's a pair. Or, for our case file, the amount of time a student studied and the test score they got. Or even something like the temperature outside and how many ice cream cones were sold that day. See? Each one is just a pair of numbers tied to one specific case.
And this is where the magic really happens. A scatter plot takes all those pairs of numbers and boom, turns them into a picture. Each pair, like one student's study time and their final score, becomes one little dot on the graph. And when you plot all the dots for all the students, you get this data cloud, and that's our clue map.
Okay, so we've got our map and it's covered in dots. Now what? Well, a good detective needs to know how to read the map, right? We need the right words to describe what we're actually seeing in that cloud of data points. Our data cloud can basically point in two main directions. First, you might see a positive correlation. That's when the dots generally slope upwards. As one thing goes up, the other tends to go up too, just like we suspect with study hours and test scores. The opposite is, you guessed it, a negative correlation. Here the points slope downwards. As one thing increases, the other decreases. Think about it, the faster you drive, the less time it takes to get somewhere. But what if the dots on our map are just, well, a random mess? No clear direction, no slope up or down? Well, sometimes that's the answer. Sometimes two things just have absolutely nothing to do with each other.
I mean, just think about it for a second. If we plotted everyone's shoe size against their exam score, what would we see? Just a meaningless jumble of dots, right? There's no connection there. and that means there is no correlation. All right, you're going to want to listen closely because this next part is, without a doubt, the single most important lesson for any data investigator. It is a classic mistake, a huge trap that's so easy to fall into if you're not careful. So let me set the scene for you with a famous data puzzle. Imagine you're looking at citywide data during a hot summer. You notice two different things are both increasing at almost the exact same rate. It looks like a super strong connection. Just look at this data. As the summer months go on, ice cream sales shoot up. At the exact same time, tragically, so do drowning incidents. The pattern is crystal clear. The two things are moving together perfectly. So, does eating ice cream cause drowning?
No, of course not. And this brings us to the golden rule. The one thing you need to remember from all of this. Correlation does not equal causation. Just because two things are happening together does not mean one is causing the other. So what on earth is really going on?
The mystery is solved when we find the hidden variable, sometimes called a lurking variable. In this case, it's the hot weather. Hot weather makes more people want to buy ice cream, and hot weather also makes more people go swimming, which sadly increases the risk of drowning. The heat is the real culprit, the true cause that connects these two trends that otherwise have nothing to do with each other. Okay, let's add another tool to our detective kit. Now that we can spot a pattern, we need a simple way to summarize it, to basically boil down that whole data cloud into one single, simple line. This is called the line of best fit, or you can just call it a trend line. It's really just a straight line that we draw right through the middle of our scatter plot. It's not supposed to hit every single dot, but it should capture the overall vibe, the general direction of the data, whether it's sloping up or sloping down. And you don't need some complex math formula to get the basic idea. If you're just drawing one by eye, make sure it follows the general flow of the dots. It should slice right through the middle of that cloud, so you have about the same number of points floating above the line as you do below it. So why even bother drawing this line? What is it good for? Well, its most powerful use is helping us make educated guesses, or to use the official term, predictions, based on the pattern that we've found. Think of the trend line as a kind of cheat sheet. If you know a value for your first variable, say a student studied for 5 hours, you can use the line to predict the value of the second variable, their likely test score. It's a way of using the overall trend to estimate a possible outcome. But a good investigator always has a code, right? Some rules to follow. First, don't try to make predictions for things way outside the data you actually collected. Second, you got to remember the line is just a model. It's an estimate, not a perfect crystal ball. And most importantly, even with a fantastic trend line, making a prediction is not the same thing as proving one thing causes another. We must never forget the causation trap. So we'll end with this. The next time you see a news story or a headline that claims two things are linked, you now have the tools to think like a real investigator. And the very first question you should ask is always this: is this just a correlation? Or is there a hidden culprit, a secret variable that's really telling the story?